Let's look at geometric series as it relates to AP Calculus. And if you want to print the sheet that I'm using for the notes, you can go to this bit.ly link down here. So let's talk about geometric series. First, the definition is a series where every term is a constant multiple of the previous term. And that constant multiple is called the ratio of your geometric series. And finding that ratio is pretty important. And so you need to know how to do that. There are several ways, but one of the ways that will always work is if you expand your series, or if the series already expanded, you can find the ratio by dividing any two consecutive terms, and make sure that when you do that, you do a term divided by the previous term. Don't do it the other way around. Don't do like the second term divided by the third term. That wouldn't work. A geometric series can always be written in this form, and this is the form I prefer, because if it's written like that, the ratio is very easy to identify. It is the number, the constant that is being raised to the n power. In geometric series, the only location for your n will be in an exponent. It'll be a constant to the n power. Now, that doesn't mean every series that only has n and an exponent is geometric, but every geometric series can be written in that form where the only location of n is in an exponent. And when it comes to convergence, a geometric series, so now we're moving into the sum of every term of the series from the first term to the infinitieth term, will only converge if the absolute value of your ratio is less than 1. And that, of course, is the same thing as saying that r is somewhere between -1 and 1. And if you want to find the sum of a geometric series, this is one of the few series that we will actually learn how to find the sum. If the series does converge, if the ratio is less than 1, the sum of a geometric series is always the first term divided by 1 minus the ratio. So a sub 1 is the first term. I maybe should define that. And one thing you want to look out for, I have written here a sub 1 times r to the n minus 1. And in that exact form, the constant here is the first term. However, it really depends on where n begins and what this exponent is. Every now and then you will see a series written in the form a times r to the n power. And I suggest to find your first term, simply plug in whatever the first value of n is. Don't assume that that is your first term, because it may not be, and we will probably look at one where that is the case later on. And let's look at a few examples. Let's determine if these series converge or diverge, and if they converge, find the sum. I'm going to point out that phrase right here. In my class, in AP Calculus, BC, you will only know how to find the sum of three types of series. One is a geometric series. Two is a telescoping series. Sorry. Two is a telescoping series, which you don't know what that is yet. And three is a recognized Taylor series, which you also don't know what that is yet. So if you are ever asked to find the sum of a series, it is a huge hint into the type of series you are looking at. It's got to be one of those three. And even among those three, you don't really need to know telescoping. That is not officially in the BC curriculum. I like to teach it because I think they're interesting. So on the AP exam, if they ask you to find the sum of a series, it will be either geometric or it will be a recognized Taylor series. And that really narrows down the thought process, because we're going to learn about a lot of series. But only those two or three are the ones that we can actually sum. So let's dive into some of these. So number one, does this converge or diverge? And the first thing I do is I notice that this is geometric. It is a constant to the n power. And in this series, the ratio is 3/2. That is greater than 1. Therefore, this series diverges. And that was pretty easy. Ratio bigger than 1 diverges. Number two, 2 times a constant to the n power. In this one, the ratio is 2/3. That is indeed a ratio whose absolute value is less than 2/3, is less than 1, which means the sum does exist and we can find the sum. That's bragging rights. We don't get to do that very much. So I'm going to find the sum by using the formula first term over 1 minus the ratio. And my first term I'm going to get by plugging in my first value of n, and 2 times 2/3 to the 0 power is going to be 2. So my first term is 2. And now I have the ratio, I have my first term, and that means I know that the sum, which I'll indicate as S, is my first term divided by 1 minus my ratio. And if you clean that up, that will clean up to 6. So the sum of that series is 6. I have 3 more examples to look at. This one, it is constants to n powers. The only location of an n is in the exponent. And so this is geometric. And there are a couple of ways we could tackle this. One, to find the ratio and the first term, you could expand the series to 2 or 3 terms and divide any 2 terms to get the ratio. I like to manipulate my series, and I'm going to change 2 to the n plus 1 to 2 to the n times 2, all over 3 to the n. And then I can rewrite 2 to the n over 3 to the n as 2/3 to the n. And so I group those and raise both of those to the n power. And then I can multiply the 3 and the 2 to get 6. So I rewrite my series in this form. And now I can see that my ratio is 2/3. That means we will converge. Absolute R is less than 1. Therefore, this converges. And it will converge to the first term divided by 1 minus the ratio. And to get my first term, I'm going to actually plug 1 in for n, and that'll be 6 times 2/3 to the 1th power. And it does continue. 6 times 2/3 is 4. So my first term of this series is actually 4. And that's an example of one where you cannot assume that the constant before the ratio is the first term. Always plug in that first value. So this converges to the sum of first term over 1 minus ratio, and that ends up being 12. Next example, n over n plus 1. That's not even geometric. But I wanted to sneak this in here just to remind you of the very first convergence or divergence test that my students learned, and that is the nth term test. Always, always, always remember that in order for a series to even consider converging, the terms must approach 0 as n goes to infinity, and these terms approach 1. That is not 0. Therefore, this series diverges. Always remember that nth term test. It doesn't work very often because if the terms do approach 0, that is inconclusive, and we would have to go into some other convergence test. However, this time we are lucky. Terms approach 1. This will diverge. Then I have one last example. Find the sum of this geometric series. Now, I wrote this one differently. It's not in that little sigma notation. I did tell you quite definitively that this is a geometric series, so I can find the ratio, and I can get the ratio by dividing any 2 consecutive terms and choose the 2 that are going to be the easiest. I'm going to do 3 and 2, or 3 and -2. So -2 divided by 3 is my ratio. The absolute value of that ratio is indeed less than 1. Therefore, this will converge to the sum of my first term, which is up here, 3, divided by 1 minus my ratio. That's 3 divided by 5/3, which ends up being 9/5. And so that one does converge to 9/5. And there is a little introduction to geometric series in AP Calculus.